Hello and welcome back. This is going to be the final lesson in the table lamp spindle 3D modeling. One thing that we still have to add to this is the national pipe thread. And that is listed right here. This is shown as a 1/8-27 national pipe thread 1/2 inch deep. So we're going to start with this. So we're not going to be doing this with a coil. We're going to be using what's called a simple thread, which is very similar to what we saw in the valve body when we did the tapped holes through the front. So this time we're going to be using just the normal thread, and we're going to set the specification. So this is not going to be a full length, and the specification here, so we have to show the face. So we're going to select the face. And so make sure this is pushed in, and then select the Q drill hole. And then click over to specification. Change this from ANSI unified screw threads to N.P.T for national pipe thread. Set the size for 1/8. And that will give you the 1/8-27 N.P.T designation. It's a right-hand thread. And we're going to go to location. Now this won't get you 1/2 inch. So it locks in a length of 0.392. So this is as deep as it will allow you to tap that hole. So all you have to do is then hit OK. And you have it, right? Now this isn't shown like this, right? These are real threads that we have coiled. This is a fake thread. So you can see the depth right here of 0.392. Lastly, let's turn this plane off once more. And we're going to add a fillet to the U.N.C thread here at the back. So we're going to click back into the hub. We're going to go back, and we're going to find this website, GeoCities, for thread info. And we're going to take a look at this image here. And one thing that we're going to add, now it shows that this is the screw, right? And then this is the nut, right? This is typically how threads are mated together. There's a screw is threaded into a nut. And it shows here an arrow, a leader, saying radius. So there should be a radius on the screw at the root diameter, and it's 0.1443, and that means multiplied by the pitch. So that's one last thing we're going to add to that thread. So we're going to come back, and we can look at this from this view, select fillet, and we're going to type this value in, 1.1443 star multiplied by 0.1429. And we're going to come in here and we're going to select here and here. And then we're going to hit OK. There. And now that's a good representation. And the very last thing we're going to do with this, before getting it ready to assemble, is we're going to change the material finish. Now this is, I've set this to aluminum, which doesn't quite, this is polished aluminum, right? You see right here. Now, this doesn't look so nice. I mean, it's okay, but let's make it look really, really nice, right? So we're going to cheat, and we're going to set this to look like chrome polished. Now that is sharp, right? And that actually looks a lot like pretty much my project that I took a photo of and showed to you in the hub. So this really catches the light on your monitor quite well, right? So Inventor generates these reflections as you do a free orbit, but that looks very, very, very sharp. So this will totally conclude the modeling completion of your spindle. So that is it. So it looks really, really nice. And the next time we talk, we'll be starting our work on the base. So that is it for this lesson. Take care, and I will talk to you later.